from Department of Artificial Intelligence and Data Science along with my teammate Varsha under the guidance of Mrs. R. Divyabadi ma'am, Assistant Professor from Aegis Pillai Engineering College, Nagapattinam. So today we are here to present our project AI-based soil nutrient dispensing system. Okay, let's go to the introduction part. As we all know, agriculture play a very important role in our daily life, but the current method of using fertilizer is not very efficient. Farmers usually apply the same amount of everywhere, but soil conditions are actually different from different areas. Because of this, nutrients get waste and cost increases, and it also affects the crop growth and the environment. So next we go to the problem statement. The main problem in current farming is the lack of real-time monitoring of soil conditions. Farmers do not have accurate information about what nutrient the soil actually need at a particular time. Because of this, fertilizers are applied uniformly across the field without considering soil variations. As a result, some areas get more nutrients while others get less. This leads to insufficient usage, increased cost and nutrition wastage. And also it affects the soil health and crop productivity. So next we move on to the objectives. So based on this problem, our objectives are: first, to continue monitor soil parameters like pH, nitrogen, phosphorus levels using NPK sensors. Next, to use AI models to predict the nutrient deficiency based on real-time data. And then to automatically dispense the required nutrient using pumps or valves. We also aim to record the data in a cloud database for future analysis. And finally, we minimize the fertilizer wastage and reduce the environmental impact. Next, we go on to the proposed system. Our proposed solution is a closed-loop architecture with the main 4 layers. Like first is the sensing layer, they are responsible for real-time soil monitoring. Next is the prediction layer, where the AI model detects the nutrient deficiencies. Then come the explainability layer, where techniques like SAP are used to understand the model decisions. The key ideas here that there is a direct connection between AI prediction and the physical action. So what are the data collection we collected are? We collected soil related data such as pH, moisturizer and NPK nutrient levels. The data is obtained either from sensor or from the existing soil data sets. It represents the different soil condition and nutrient variations, which help the model to understand and learn the pattern efficiently. Then we go on to the data pre-processing. After collecting the data, we perform the data pre-processing. First, we do the data cleaning, where the missing values are handled using mean or median, and any outliers are identified and treated. Next, we perform future scaling, where the data is normalized to a range between 0 and 1. This helps in standardizing the data and improve the performance of the model. Then we go on to the future engineering. We selected the important features like pH, nitrogen, phosphorus, potassium and moisture, because these are the most critical factors that directly affect the plant growth. We also created the derivative features called nutrient deficiency index, which help in summarizing the overall soil health. These features are chosen because they are directly measured using sensors, as they have a strong relationship with fertilizer requirements. Since the number of features is already small, dimensionality reduction is not required. System architecture. Our system architecture is a closed loop with multiple stages. First, the sensing layer collects the real-time data like NPK values, pH and moisture using sensor. Next, in the processing layer, the data is analyzed and the AI model predicts the nutrient deficiency. In the explainability layer, we verify the model decision and understand the future importance. Finally, in the actuation layer, the required nutrients are dispensed automatically using the pumps. The entire process works in a continuous loop, where the system keeps monitoring, predicting and updating based on the real-time data. Next, we move on to the model development. During model development, use decision tree and random forest algorithm because they give good accuracy and they are easy to understand. The system flow is simple. Sensor collect data. ESP32 is going to the cloud AI model. Then nutrient dispense the required amount of nutrient. The goal is to identify missing nutrients and suggest the correct amount. Then model implementation. For model implementation, we developed the system using Python. First, we installed recurve libraries like NumPy, Pandas, and scikit-learn. Then, we created a synthetic dataset similar to real soil data, including values like pH, nitrogen, phosphorus, potassium, and moisture. After that, we perform data pre-processing and split the dataset into training and testing data. Next, we trained the random forest model using the training data. Then, we tested the model using tested data and generated predictions. Finally, we evaluate the model performance using accuracy score, classification report, and confusion matrix. System workflow. Our system workflow works step by step. First, the farmer enter the basic details like soil type and the land area through the web interface. Next, the IoT sensor collect the real data such as NPK levels and moisture and send it to the cloud using ESP32. Then the AI model analyze the data and compare it with the ideal values. If any nutrient is low, it detect the deficiency. After that, sharp analysis explain the reason for the prediction, like which nutrient is lacking. Based on this, the system automatically dispenses the required nutrient in the correct amount. Finally, the sensor check the soil again and confirm the soil balance is achieved. Evaluation and refinement. In the evaluation and refinement phase, we tested the model using metrics like accuracy, precision, recall, and F1 score to check how correctly it predicts the nutrition deficiency. Next, we improve the model using hyperparameter tuning by adjusting the value like number of tree and tree depth in the random forest algorithm to avoid overfitting. Finally, our model is accuracy increased from around 85% to 91%, which help in making more accurate nutrient decision and reducing wastage. Performance result. The confusion matrix show that the model predict the nutrient deficiency correctly with the very minimal errors. Also, the correct accuracy improved from around 87 to 91% after optimization, which show the better performance. Then last of the conclusion, limitation and future work. So to conclude, our system monitor soil in real time and supply nutrient only when required and in the right amount. This help in reducing fertilizer wastage and improve the overall crop productivity. However, these are the some limitations like high initial cost and a need for internet. In future, we can improve this system using weather prediction, GPS and solar system to make it more efficient. So this is my IEEE conference paper with the title of Closed Loop AI-based Soil Nutrient Dispensing System for Precision Agriculture under the guidance of Ms. R. Divya Bharti ma'am and my teammate with Varsha. Then this is my conference paper certificates issued by the Sir Isaac Newton College, Nagapattinam. So now we go into the demo video of my project.
Hi, this is my project Closed Loop AI Powered Soil Nutrient Dispensing System for Precision Agriculture. Let me show you the setup. First, here I have the soil sensor. This include the NPK sensor and the soil moisture sensor. These sensors are placed in the soil and they continuously measure the nutrient levels and moisture conditions. Along with that, this is the moisture sensor and this is the temperature sensor used to analyze the temperature of the crop to predict the nutrient level, and this is the NPK sensor used for analyze the nutrient levels in the soil and monitor how much nutrient are required for the soil. In the app, I can monitor the live values of nutrient, moisture, temperature. At the same time, the balanced AI logic analyzes whether the soil need nutrient or not. Now coming to the section, here I have relay module connected to a ESP32. This relay work like a switch. Based on the AI decision, the ESP32 send a signal to the relay. The relay is connected to the pump system. Here you can see that tank container which hold the nutrient solution. When the relay turn on, the pump start and supply the nutrient from the tank to the soil. After dispensing, the system does not stop. Again, the sensor read the updated soil values and the ESP32 check whether the nutrient level is sufficient. It is enough, the pump turns off automatically. So this process keep repeating continuously. That's why it is called closed loop system. And here you can see the wiring connections which connect all the components, sensor, ESP32, relay and pump. This is fully automatic and ensure that only the required amount of nutrient is supplied. That's my project. Thank you.